Hi, this is Codeforces question, binary inversions. We are given a binary array, and binary array means that all the values on the array either 1 or 0, and we need to find the maximum number of inversions. The number of inversions in the array is the number of arrays of indices ij such that I less than j and a of y greater than aj. That means for every one we need to find all the zeros after it, and every zero will form a pair or inversion with 1. So this is one inversion because it has 1 at the beginning, then it has 0. This is another inversion, this is another pair, and this is another pair. For this one we have 4 inversion. Then we need to find the number of inversion for the next one. So we have 1, 2, 3, so 4 plus 3. Then for the next one, 1 and 2 and 3, so plus 3. And for the last one we don't have any 0 after it, so it has no inversion, or it's not part of any inversion. So the total number of inversion here is 10. Now in the question also it's given that we can you are allowed to perform one operation on it at most once. In an operation you can choose any element and flip it, turn a 0 into 1 or vice versa. So we can pick any number from the array and flip it. If it's 0 we can change it to 1, or if it's 1 we can flip it to 0, and we see if we got a number greater than 10. If we have a number greater than 10 we return that number, otherwise we return 10. So first of all what we need to do is to find the original number of inversion. Assume it's x, and so our answer become x. Then we need to find the maximum number of inversion if we flip from 0 to 1, and let's call it y. And if y is greater than x we assign it to the answer, other y's the answer will remain x. Then we need to find the number of inversion, or the maximum number of inversions if we flip 1 to 0, only one entry. And if this z is greater than the answer, then the answer become z. And to switch from, or to flip an item from 0 to 1, it's required to get better answer than the original answer, that the number of ones before the item that we flipped is less than the number of zeros after. So assume we are flipping this 0. Here we have 1, 2, 3, which is the number of ones before. So we have 3 ones before, we have 2 zeros after, and this means that after we flip this to 1 we will lose 3 pairs or 3 inversion, and we will gain 2 new inversion, because this 1, 1 0 1 0, these are 2 new inversion, and we lose 3 inversion, which is the number of 1 before. This is why this is a bad solution. and in order to gain more inversions, the number of ones should be less than the number of zeros after. And to maximize the answer, or to have the best answer, we can select the first zero in the array, and by this we guarantees that the number of ones before zero is the minimum. So to solve this, we select the first item or the first zero in the array, and we calculate the answer y. Then for this we need to switch from 1 to 0, and to have or to increase the number of inversion from the original inversion x. The number of ones before should be greater than the number of zeros after. So assume we are flipping this 1 to 0. The number of ones before it is 1, 2. We have 2 ones, and the number of zeros after it is 1, 2, 3. So the number of ones before should be greater than the number of zeros after. And this is because when we flip this one to 0, we gain here the number of ones before, we gain 2 new pairs, 2 new inversions, and we lose 3 inversions, because this is 0 with 0 is not inversion, so we lose 3 inversion. This is why the number of ones before should be greater than the number of zeros after. And to have the best result for this, we can select the last one in the array, which is this one, and to flip it to 0. This is because the number of ones before is the maximum number. Here we have 1, 2, 3, and there is no zeros after. So to solve z, we need to flip the last one to 0 and find the number of inversions. And to find the number of zeros for any item, we build a matrix or a suffix matrix. We iterate from right to left, and we store for every entry how many zeros until up to this entry. For example, here we start with 0, number of zeros. Here there is 0, we increase it to 1. Here we have another 0, so it's 2 zeros. For this we have 3 zeros. For this one we have, it's not 0, so we take the value from the next entry in the table, and we use this table, which is suffix 0, to count the number of zeros after. Let's see the implementation. So this is the array that calculates suffix 0. Here it takes a vector and the original array and the length of the array. We fill the suffix 0 array with 0, and as we said, we loop from right to left. Then this function calculates the number of inversions. So we need to loop over all the item from left to right. If the item equal to 1, we use the suffix 0 array to count the number of 0 after this item, and we added it to the answer. And as we said, our algorithm first solve it without any flipping. So first of all, we need to get the number of inversions for the number of the array and store it in an answer. Then we need to check the first to find the first 0 in the array, and we flip it to 1, then we calculate suffix zeros again, and we compare the answer with the new number of inversions. If the new number of inversions is greater, we will assign it to the answer. And we need to now so after this we flip the element back to 0 for the next step. The next step is to calculate the last or to find the last item, the last one in the array, and we flip it to 0. We calculate the suffix zeros array again, then we get the number of inversions. If it's greater than the answer, we assign it to the answer.